Hi everyone, back with our latest edition of Quadratics in Quarantine. So in this unit here, our second quadratic unit, we're going to get into a lot of factoring coming up next class. Factoring, for lack of a better definition at this point, is sort of the opposite of multiplication in a lot of instances. So last day, and I apologize for the super long video last day, but we had to go over and review multiplication of binomials and trinomials and polynomials. And today we're going to do that with a little bit of a focus in on a couple special questions. And products, of course, means the answer to multiplication. So we're going to look at a couple special instances here. And this is going to help you when we get into factoring. If you can recognize these special products, then factoring them becomes a lot easier. Just a review from last day, we were multiplying out binomial by binomial, and when we do that, we FOIL it out. So our firsts, our outsides, our insides, and our lasts. So if we quickly do that, we would have 2x times 3x is 6x squared, 2x times 5 is plus 10x's, negative 1 times negative 3 is negative 3x, and negative 1 and 5 is negative 5. And of course, we can simplify by putting those together. And we get something like that. Now, this was when we multiplied together two different binomials. A couple cases we're going to go over here. So let's simplify this one. So this is x plus 3 squared. And what that means is x plus 3 times x plus 3 twice. We are taking the base and we're multiplying it by itself twice. And if we FOIL that out, we get x times x is x squared plus 3x plus 3x plus 9. And we'll just simplify x plus 6x plus 9. And let's do another one of these. 3x minus 2 squared. That's the same as saying 3x minus 2 times 3x minus 2. When we FOIL this out, 3x times 3x is 9x's squared. 3x times negative 2 is minus 6x. Negative 2 times 3x is minus 6x. And negative 2 and negative 2 is positive 4. And simplifying, we get this. Now, I don't know if you can see a pattern emerge in here, but there's a shortcut. So if I was to solve these questions or simplify these questions myself, I wouldn't need to do these steps. And I'm going to show you that shortcut here. So first of all, the first term of our binomial has become, the first term of our binomial squared becomes the first term of our trinomial answer. The second term of our binomial, when we square it, becomes the third term of our trinomial answer. Same over here. And you'll notice here that I had a positive, here I had a negative, did that on purpose. Our 3x squared becomes the first term of our answer. Our minus 2 squared becomes the third term of our answer. And so, in this case here, I'm going to write the rule out like this because I think that's the way it's in your notes. So we have an a plus b squared situation. We are going to get an a squared as the first term of our answer, b squared as the third term, and in the middle, we're going to get, and that was a positive b squared, we're going to get this. The middle term here is twice the product of the terms. Product just means times. So what I did was I took A and B and multiplied them together, A times B, and since it's twice that, I doubled it. So you can see over here the same thing. We did 2x, or negative 2, times 3x, which is negative 6x, and we doubled it and got minus 12x. 3 times x is 3x, double it, 6x. So let's go through a few examples where we can practice doing this. So x plus 4 squared. You can FOIL this out and get the answer. Once again, I'm showing you this and I want you to practice this because it's going to help you when we get into factoring going the other way. So I can take my first term and square it. Take my second term and square it. And my middle term here is going to be double these two together. So 4 times x is 4x. Double it, we get plus 8x. How much fun is this? Another special term. Now you might be saying, well, why didn't we use this yesterday? Just going back to yesterday, we have two different binomials here that we're multiplying. When we have two different ones, we have to FOIL it out. Today, it's the same one. It's x plus 3 times x plus 3. 3x minus 2 times 3x minus 2. So in each of these cases, we are we're multiplying by the same base, so we can take this shortcut. So here we have an x squared. Negative 1 times negative 1 is plus 1. And our middle term, negative 1 times x is negative 1x. So negative 1 times x is equal to negative 1x. And when we double that, we get negative 2 x's. All right, same thing. 3x squared is 9, or sorry, yeah, 3x squared, so 3x times 3x is 9x squared. So we take the coefficient, 3 times 3 is 9, x times x is x squared. Likewise here, take the coefficient, 2 times 2 is 4, y times y is y squared. So all that review from the long lesson coming back to help us here. And what we're going to do is we're going to multiply our two terms together. So we know that 3x and 2y when multiplied together is 6xy's. And our middle term is going to be double that, so plus 12xy's. I don't expect you to do this. I'm just writing that down to help you follow along. Obviously, you can't be asking questions, so if you say, you know, where does the 12xy come from? Now you kind of know. And that's been the hardest part of teaching you guys over the distance learning is I'm just sort of yapping away here, talking to myself. I don't have the feedback of your facial expressions or your hands going up. So it's actually kind of hard trying to teach you with absolutely no feedback during the lesson. I don't know if you're understanding this or not as I'm teaching it. All right, so another example here. Let's double this, or not double it, square it. So 5 squared is 25. A squared is a squared. Negative 4 times negative 4 is positive 16. B squared. And here, when we do the 5a times minus 4b, we get minus 20 ABs. We double that, and we now have minus 40 ABs. A nice easy one here again. X squared plus 25. Negative 5 times x is negative 5x's. Double it is negative 10x's. And to some degree, I know I haven't reminded you of this in a while, but when I write a question like this, a great thing to do is to pause it, especially after you think you know it. Try doing this question on your own, and then pressing play and making sure that you've done it properly. So we have 4x squareds plus 25y squareds. Negative 5 times 2 is negative 10xy's. Double it, that's negative 20xy's. All right. So in all these cases, we either did x plus 4 times x plus 4, or x minus 1 times x minus 1. We're going to jump to another situation here, and that is what if the signs are different? So let's FOIL this out. We get x squared minus 2x's plus 2x's minus 4. And when we simplify, minus 2x's plus 2x's are 0x's. So we just get this. And just a title for this section here is the product. So that means when we're multiplying of a sum and a difference. Sum means to add, difference means to subtract. So here we're adding, here we are subtracting. And if we do another example here, 3x minus 4 and 3x plus 4. So you notice the terms are, the first terms are the same, the second terms are the same. Same thing over here. Just we have a sum and a difference. Doesn't matter which order they're in. FOIL this out. 3x times 3x is 9x squared. 3x times 4 is plus 12x. Minus 4 times 3x is minus 12x. Minus 4 and positive 4 when multiplied together are negative 16. Simplifying, we get 9x minus 16. 12x's minus 12x's is 0x's. And I know you're all sitting there saying, I can see a pattern emerging. Here our first terms got squared. Our second terms got squared. In this case, we don't have a middle term. Likewise here. Oops. First term squared. Second term squared. And in both these questions, I will point out when we're doing difference of squares, we're going to have a negative second term. So our rule here is if we are doing a plus b and a minus b, we are going to get a squared minus b squared. So you square the first term and you square the last term, and it will be a subtraction every time. And so we call this difference of squares. So let's practice a couple, and that'll be that nice short lesson for you. So x plus 7 x minus 7. Let's square the first term, and let's square this the second term here. 7 times 7 is 49, and as I mentioned, it'll always be a negative, or negative 7 times 7. So square the first term here. We have 25c squared, and we have minus d squared. That's all there is to it. All right, and a word problem. So we have a parabola with the equation of y is equal to x minus 3 squared. What are the coordinates of the vertex? So we can look at this in a couple different ways. Some of you may be looking at this as a vertex form equation for a parabola. Some of you may be looking at it as a factored formula. And this is why we're going to be getting into factoring coming up. We can start to move between different relationships. So in this case, for the vertex, we know that we are moving right 3. And we're not moving up or down. So our vertex is at 3, 0. Here we know that we have our zeros. If you just want to look at it graphically, we know that we are crossing the x-axis at 3. We know we're also crossing the x-axis at 3. So that tells us that we only have 1, 0 in this case. Our parabola is only touching the x-axis at one spot. Once again, it's at 3, 0. So whichever way you are looking at this, you're going to get the same answer. So that's the coordinates of the vertex. If we want to change this into a standard form, we can expand this out. So y is equal to x minus 3 squared. That was our original formula. So there it is, foiled out. Of course, I'm hoping none of you foiled it out. I hope you used what we learned today. So x squared, negative 3 times negative 3 is positive 9. Negative 3 times x is negative 3x. Double it, you get negative 6x. So what we learned today is obviously a shortcut. I've eliminated a couple lines here. But not only that, as I said, the true value of this, and it's why I want you to practice it in this form, is we are going to start factoring it next day. So you may be given equations like this, and you have to put it into factored form. And so you're going to be going backwards. And so having an understanding of what we're doing today would help out greatly. And I think part C of this question is verify the coordinates of the vertex satisfy the equation. So this is our vertex. Does it satisfy the equation? So let's take our equation here, sub these in. 0 is equal to 3 squared minus 6 times 3 plus 9. 0 equals 9 minus 18 plus 9. 0 equals 0. We are happy. That's a check mark. Life is great. All right, good luck with the homework. If you have any questions, please don't hesitate to contact me and I'll send you off a solution. There we go, video less than half of last days in length.